GM.
Hello, BZ.
You sound. It sounds like you have slept, Jacob. I don't know.
I have not. Let me tell you that.
Oh, okay.
But I just went and played a soccer game and won, so definitely in a good mood.
Well, that's why you're like in such a good mood. I'm like, what?
What do you mean? I'm not normally in a good mood?
Okay, no, normally you are, but like you just sound. I don't know. It just sounds like you've gotten sleep. I don't know.
Oh yeah.
Yeah,
Time for Emerald Academy, baby. Let's get it.
yeah. I got like it's 3 a.m. Like for me right now, and
Oh my.
yeah,
It's 3 a.m. for you? Oh yeah, that's right. That's right. Yeah. I remember that now.
yeah.
Wow. You gotta get some sleep, BZ.
Yeah, after I like looking at some pills, I think, and after this office hours.
Yeah, of
So
course you wouldn't miss the office hours, right?
yeah, um,
Yeah, today's workshop's gonna be pretty short, and very easy, just because it's like the first few days of Emerald Academy, and I don't think people have like gotten time to really explore cadence yet. So we're just gonna be doing some like um, very basic stuff. So it should be fun. Hey there, Davon. SWT. SWT. I love the check mark that you always put in, although I don't know how to get it. Hey there, Angie. Happy to have you. Yeah, that check mark, SWT. How do I get that? Besides just copying it, I guess. Oh, I can join server. Oh, nice. Yeah, it's totally fine, busy. Don't worry about it. So we're gonna start in like maybe like 3 more minutes. Usually it takes people a little while to roll in, or people are shy to join first. But I'm also currently I mean, not that this matters to you because all of you are watching this live anyway. But I'm streaming this on YouTube right now, um, so that in case anyone wants to go back and watch the recording, they can. Just out of curiosity, what time is it for all of you right now? You can type in the text channel. 8 p.m. Oh, it is for me too. It is for me too. Yeah, I'm in oh, really? So we're all in Central Time, is that right? Yeah, I'm in the Chicago area, so Houston. Nice. All right. So yeah, so about a couple more minutes. Nicely iced. Welcome. Happy to have you. Bruce. Hey, Bruce. Good to see you too. Bruce, how's your course going? I can't hear you if you're talking, by the way. I know you were trying to unmute your mic. Probably fine if you don't want to. Hey there, Ashley. All right. So I'm going to go ahead and get started. I don't think this is going to take that long. So if it's getting late for you, don't worry about it. We're not going to be going on for too long here just because we've only been through a few days so far. But we're just going to overview some of the basic stuff during the first chapter and also like a little bit of chapter 2. If you have to drop out at any time, don't worry about it. I'm recording this right now and I'll post a link to it later. And yeah, that's all I have to say. Oh, and you can type in the text channel that is right above where we're all in the voice channel. And welcome, Paladin. Happy to have you. All right. So Yeah, so what we're going to do with these workshops is we're really going to just overview some of the things that we've done, and then we're just going to work through a couple examples together, just to make sure that we understand everything that's been going on so far. And then after we do that, I'm just going to pause and just do office hours for however long people want. If they have any questions or want to ask me, literally anything. Um, this is a chance not only to ask about the boot camp, but if you have any questions about Flow or the blockchain in general. Please let me know, and we can talk about it together. All right, cool. So we're going to start out just overviewing chapter 1 a little bit. Just going to skim through it. I'm actually going to go right down to the quest because I assume that most of you have probably read through this. And if you haven't, it really just talks about like what a smart contract is. And I think the most important things about this day is talking about the downsides of smart contracts, because in order to really understand something, it's important to understand why they can be harmful or dangerous. And so in the case of smart contracts, right, we know that they're hard to get right because once you write a smart contract, you can never, it's really hard to redeploy it, right? So we really want to make sure we get it right in the first go. They can be malicious, and I'm looking at the thing here. Hey, Claymore, I'm really happy to have you, and Sport Monkey as well. Yeah, so they're hard to get right. They can be malicious if the developer is mean, right? So smart contracts, they handle a lot of really important stuff, whether it's tokens or actual monetary value or voting rights. And so smart contracts are important. And so they can be malicious if the developer is mean and writes it in a weird way. And the other thing is that, not everyone understands smart contracts, right? It's easy to sort of get baited into participating in a token drop or something. And most of those people, unfortunately, are not technical. And so it's easy to sort of get people to falsely sign a transaction.
I ate those leftovers already.
Oh, Claymore, I think you're unmuted.
They're so good.
Claymore, I think you're unmuted. I don't know if you can hear me, but I'll mute you for you, just in case. Okay. So yeah, and then exactly like I said, you can't undo something once you put it out there, right? And then I think the one last thing I'll say from this chapter before we move, or from this day before we move on, is this quest right here, right? The difference between a script and a transaction. Now, the reason it's important to talk about this is because scripts and transactions are pretty much like everything we're going to be working with throughout this boot camp. Contracts, scripts, and transactions. And the main difference here, I guess, well, I'm going to give you all a chance to sort of give me a guess here. Some of you have actually already completed this quest, but does anyone know what the difference between a script and a transaction is? And I'm looking specifically for which of these can modify data and which of these is free. Exactly. Yep. Just like Sport Monkey said. And I see Davon's probably going to say the same thing, right? So yeah, so scripts are read-only. So this means that you can't... I was trying, yeah. Yeah, it's hard to type quick, but that's the main idea, right? In a script, you can't change anything about the blockchain. You can only read, right? Whereas in a transaction, you can change stuff about the blockchain, and you can access a user's account, right? And it also costs gas. Now, on blockchains like Ethereum, gas can be hundreds and hundreds of dollars. On Flow, it's fractions of a cent. Now, it won't always be that way, but this is one of the, Flow is designed not only through the proof of staking model, but, it's designed in general to keep gas costs really low. And so it's really good for onboarding users into the blockchain space and helping people actually deploy real applications, right? Because who wants to have an NFT drop on Ethereum if each NFT costs, $200 to mint, right? It's crazy. So that was the main part of day 1 that I really wanted you to get out of that. And then day 2, this was talking really about flow specifically and cadence, right? And so this talks a lot about the cadence language pillars. And, this isn't too important. If anything, I have, forget these pretty much all the time. And you never really think about these. But it's important as a beginner to understand why Flow is putting this on their main page. Why is it that the Flow team has decided to put developer experience as their number 4, great thing they're doing? And it's because cadence is very, very, very easy to read once you get a gist of how the language is written. Whereas in things like Ethereum or on Solidity, I've been a Solidity developer for almost 2 years now, and I still have no idea what half the contracts are doing. And you read online all the time that, NFT projects were rug pulled, a token drop rug pulled, all that kind of stuff. And that you rarely see that happening on Flow. Now, of course, it's because, you can't really deploy on mainnet on Flow right now, but it's also because it's really easy to understand when someone is malicious on Flow, whereas it's harder on other languages. And so that was really the biggest important thing here. And then, of course, the other ones, this one's probably really important as well, safety and security. On Flow, because Cadence is so strongly typed, you don't have to understand what that means just yet, but you will by the end of this boot camp. You'll understand why it is that Cadence is so securely typed and why that's really good for safety and security. Because it's impossible to return something that you didn't mean to. And then lastly, resource-oriented programming, which we'll see a lot during Chapter 3. And this is probably the most important thing you'll learn during this bootcamp is resources. Because resources are pretty much the core of Cadence. And yeah, so these were really just free response questions asking you about, what you thought about this day, why you think these might be helpful. But I'm not going to answer these in the workshop only because I think it's helpful just to think about these on your own. And like I said, these aren't really that important, but it's good to start thinking about these as a beginner, especially before we jump into some code. So then we're going to go to Chapter 2. And I sort of sped through Chapter 1 just because I want to get to coding because I think it's more fun. And it's better to watch, like me actually coding than probably talking. But this day really gets into smart contracts. And if you haven't gotten to Chapter 2 yet, that's totally fine. We're actually going to walk through a lot of this together right now, so we can learn a lot about it. So the first thing that's really important is immediately when we start jumping into code. Oh, and by the way, I forgot to mention, if you've never coded before, and I mean like literally never coded before, and you don't know like what basic programming fundamentals, like what a function and variable are, I included a chapter 1.5 that I marked as totally optional. There's no quests here, but this is sort of a chapter that teaches you how to program and what programming means and what functions are and what variables are and all that kind of stuff. So I'm not going to walk through this just because I think most of you have probably developed to some capacity before, but this is just a helpful little chapter, to help you start thinking like a developer if you've never been a developer before. So that's there for you. All right, so let's go to day one together. So immediately, you're welcome, SWT. Yeah, totally welcome. And if you have any questions about that, let me know because I'm more than happy to sort of get you introduced to programming in general. Okay. But also, I will say that by learning the beginnings of Cadence, like you will get an understanding for programming as a whole, because the best way to learn programming is definitely to practice. That's the only way to learn. If there's any advice I have for you, if you're just starting programming, it's do not go down the rabbit hole of watching YouTube videos and reading articles. You'll never make significant progress. The only way to really improve is to start writing code and mess up a lot. And I promise you that. Okay, so the first thing I show you before we start writing Cadence code is the Flow Playground. So what is the Flow Playground? Well, let me actually open up a totally new playground here and drag this over. And, we're looking at a lot of stuff. So let me first say that this project tab, you can totally ignore this. I don't know why they added that, to be honest, but you can totally ignore that. We're going to be looking under here. These are all the accounts, and this is a transaction and a script. Now, we're going to talk a little bit about what an account is really quick. So an account you can think of as like a person, right? And you can see that Flow even makes this kind of easy to understand because they put these, cool little avatars here to show you that they're people. And accounts, you can deploy contracts to them. So that's how you usually do things on the blockchain is you take a contract like this, for example, and you put it in an account, right? So that's really what the account is doing. And we have a bunch of different accounts that we can deploy different contracts to if we want, but we're going to be using account 1 just to make things easy, okay? So this is the Flow Playground. And you can deploy contracts under the accounts. You can run transactions under the transaction template section. Sorry, and you can also, run scripts under the script templates, right? This is pretty cool. Now, what we're going to be doing today is we're going to be walking through like a very basic, very, very basic contract to help us learn a little bit about, coding and also about what smart contracts are. Now, let me quickly mention that by the end of this boot camp, which is 3 weeks long, or really however much you want to learn, we're going to completely understand all of this. So you're going to be writing contracts that are this complex, and I really believe you can do it. And even this one as well. So we're actually going to deploy both of these. So even though it looks really intimidating, it's actually really cool that this is what you're going to be building up to. And the reason I'm showing you this is because while we are starting out simple, and maybe this is a little boring, this is really crucial to getting to a point like this where we're deploying our complete, NFT contracts. So by the end of this bootcamp, you're going to be deploying your own NFT contract, which is going to be pretty cool. But, we all start somewhere. So let's go ahead and start in this base contract. Now, the first thing to do when you're making a contract is obviously to, open up a contract. So let's go ahead and say pub contract, and let's just do Jacob, right? So we're going to open up, and that's what the syntax is to make a new contract. Now, in here, there's nothing going on. All we've done is we've just made a new contract called Jacob. And remember, contracts are always pub and then contract, right? Cool. Now, in the chapter here, we sort of walk through a little bit, but we talk about what's an address, right? Where do smart contracts live? We already talked about that. And then we start getting into some contract code. And what we do here is we make a little greeting and we initialize the greeting to some sort of value. Let's go ahead and do that together, right? So inside of our contract, let's say, in order to make a variable, for now, we're always going to put pub, right? This just means that anyone can read this if they want. And then for now, we're also just going to put let. And let means that once we, put the value of this variable, we can't change it. And I'll show you what that means in a second. So let's say greeting. This is the name of our variable. And the type is going to be a string. So if you've never programmed before, a string is basically like a type. And this just means that this greeting variable right here is like a piece of text. So for example, I'm going to put a comment here. It could be like this, right? So it could be like a bunch of whatevers, or, or it could be like hello world, right? So those are both strings, but it's not, a number. Like it's not 10, right? Because that's an integer. So this has to be like some sort of string. And I can show you that too. So if we open up an init function, an init function is what gets run when the contract is deployed. So this is when you say, you know what? I want to put the contract out there for people to use. Now, of course, when we deploy this in the Flow Playground, no one can actually see it because this is just like a testing suite. But it's helpful for us to be able to test out. So let's, in our init, look at this error here. It's saying, and actually, let me increase the font size. Maybe hopefully that helps people see better. It says missing initialization of field greeting in type Jacob, right? So in this contract, it's saying we're missing an initialization of greeting. And the reason for that is because we're not setting greeting to anything. If we were to deploy this contract right now, greeting would just be nothingness, and that's not okay. So we have to say self.greeting equals hello world. Or let me just say hello idiots, because you're all cadence idiots. So if I say hello idiots here, then, we initialize greeting to this sort of string, right? And that's really cool. Now, yes, and it says invalid end of string literal, so I think it's just being glitchy, which leads me to my next point here. Okay, of course, yeah. So let me just mention really quickly that the Flow Playground is very buggy. So sometimes if you get errors, it's not actually your fault. You just have to refresh the playground like I did just right there. So I just want to point that out because that'll come up a lot. And it kind of stinks, but it's the best we got. Cool. So look, we have our greeting variable here, and we have hello idiots. Now let's see what happens if we try to do self.greeting equals like goodbye. Well, let's see what happens. So it says cannot assign to constant member greeting. And the reason for this is because we set greeting to some value right here. We set it to some value. Now this is let, and let means, right? Let means once we set the value, we can't change it. So in this case, it's saying, hey, this is let, so you can't change it again. But let's say we made this var. Var means we can change it whenever the heck we want. So now it's not complaining. And when we deploy this contract, it's basically going to be about, when this contract is going to set it to hello idiots, and then right afterwards, it's going to set it to goodbye. So we can actually go ahead and deploy this contract. Boom. and it says deployed to contract, deployed to account 1. And because this contract, in this make-believe world, this contract is out there, right? So people can look at this contract and try and figure out what this greeting is. And remember what we just said. What's the difference between a transaction and a script? Which one of these do you think we want here to read this variable? You can type it in the text channel. Whoever types it first gets a virtual hug. Nice, Ashley. Nice. And good job, SWT. Good job to both of you. So we're going to go to a script here, right? So let's go ahead to a script and read this. Cool. So I'm just got a ping. Just want to make sure I have this all right. Okay, yeah. Cool. All right. So inside of here, this is a script. Now, we're looking at some interesting stuff here, right? So what is this public function main, and why is it returning an int? Well, let's actually go ahead and just delete some of this base functionality here, because we don't want this for now. And well, inside of a script, what happens here, when you click this execute button, it's going to look for a function called main. So I'm pretty sure if we call this like hello or something, and we try to like log like hello, I'm pretty sure it won't even work. Let me try it. Yeah. So you have to name it main, and it'll do that for you, but you have to make sure you name it main, right? And if we click execute now, you'll see it actually logs hello. So main is just the function that it's looking for, okay? And we declare this function with the public. We always use public for now, and then function, right? Because it's not a variable, it's a function main, right? And a function, for those of you that haven't programmed before, is basically some wrapper around code that will execute. All right. So in here, we want to get this greeting somehow, right? And remember, it's public, so everyone can read it. But how do we do that? Well, we have to get it from the contract. So we have to first import Jacob from account 0x01, because that's the account that Jacob lives in. And then we can say, return Jacob.greeting. And we have to make sure that we specify a return type here so that it knows what type we're returning. So you put colon and then the type, which is string, right? Cool. And let's see what happens if we put we're returning an integer. This mismatched types, expected integer got a string, so of course we just make this a string. So if we execute this now, it says the type is a string and the value is goodbye. And that's what we expected, right? Because inside of our init, when this contract was deployed, we set it to hello idiots, and then we immediately set it to goodbye right after it. So this just doesn't even matter, right? So let's just go ahead and delete this because I just wanted to show you that. All right. So that is a basic greeting variable that we're defining here. Now let's do another one, right? So let's say public var number, and this is going to be an integer, okay? And so when this contract gets deployed, we want to say self.number equals 0. I don't know, something like that. Okay, cool. Now, of course, yeah, so, the flow playground is unbelievably buggy. But if we just refresh the page, it will be back to normal. Cool. So if we go ahead and redeploy this contract, let's redeploy it. Boom, it's deployed again. Oh, and that's important to know, by the way. When you make changes inside of your contract, you have to redeploy it again. Because if we make a change and don't redeploy it, then the blockchain doesn't know that we changed anything. So we have to make sure that we redeploy the contract again so that the blockchain knows that, something changed in our contract. So now if we go to our script, let's actually add a new script. Let's click this add button here, and it'll make a new script for us. So public function main is going to take in no arguments, and we want to return an integer. And the integer is going to be jacob.number, right? So return jacob.number. And of course, we have to remember to import our contract again. So let's go ahead and import it right here. And then we can execute again. And we have to refresh the page because the playground stinks, and click execute. Boom, just like that. All right, so there we go. Now that is basically all of chapter 1, day 1. If you understand that, you understand everything that was in this chapter. So that's perfect. All right, now let's go on to day 2, right? So day 2 is where things get a little more interesting because we start to change some of the stuff inside of our contract, right? So what if we, after this contract was deployed, what if we wanted to change our greeting to a different string? Does anyone know how we would do this? You can type in the chat, or you can unmute your mic if you want. Method. Yep, exactly. Good job, Paladin. Yep, exactly. So we can make a function to change this greeting string right here, right? Let's go ahead and do that. So of course we're going to use public for now. We'll talk about that later. Function, that means this is a function, and we're going to name this like, I don't know, change greeting, right? Boom, change greeting. Then we're going to open up our brackets, and that's that. We're just going to put some functionality in here. Now what we want to put in here is, let's just say self.greeting equals like so we said hello idiots, now let's say goodbye idiots, right? Boom. So we can go ahead and deploy this contract. And there's a buggy, so let's go ahead and just refresh. Put the thing there. It's all right, and let's deploy this contract. So boom, now it's deployed, right? So let's go ahead inside our script and read our greeting. So let's execute, and it says it's hello idiots, which makes sense, right? Because when we deployed the contract, we set it to hello idiots. Well, let's try and change it to goodbye idiots, right? And in order to change it on the blockchain, we have to make sure we run a transaction, because now we're changing data. Go into a transaction, and it's already set up a lot of this for us. Of course, the name of this contract is wrong. We're actually importing Jacob from OXL1. And let's go into the execute phase. So really quick, let's talk about the difference between prepare and execute, right? What is the difference between these two? Well, let's actually look at, I'm pretty sure I wrote up yeah, so here's a little diagram that I wrote up to help us understand the difference between what's in the transaction and script, right? So modifies the blockchain, use the blockchain. We know that, right? Cool. Now, here's the actual code difference. So a transaction looks like transaction. It has a prepare and an execute, which is what we're seeing here, right? A transaction, a prepare, and an execute. And this transaction can take in parameters if we want, but it's not going to take in anything in this case. And then a script is public function main, which is what we were just looking at, right? Cool. So in the transaction, look at what it says. This can access the signer's account. So on Flow, we store all the information that we want a user to have inside the user's account. And we can't access the user's account anywhere except for when we have the auth account. And we only have the auth account when a user signs a transaction. So when you sign something, that means I'm okay with this transaction. I want the transaction to look at my data. So in this case, this account said to this transaction, you can look at my data. And we can select who the account is by just clicking one of these people. Now, in a real world scenario, it wouldn't be this easy, right? For someone to sign a transaction, you have to basically sign it with your private key, which you wouldn't expose to anybody, right? So you can't just get anyone's auth account. It's impossible unless you somehow have their private key. All right. So because we're not accessing any data in the user's account, we're trying to change it in the contract, we can just go to the execute phase, right? But like I say in the chapter, you can technically do everything in the prepare phase, but I like to split it up because it makes more sense to me. So inside of the execute phase, we're going to say Jacob, let's actually log Jacob.greeting, and then let's say Jacob.changeGreeting, like this, and then let's log Jacob.greeting right after we change it, right? So I'm just going to refresh this just in case. Cool. So let's just go ahead and run this with account 1, and let's send it. And look it says hello idiots, then it says goodbye idiots, and that's because we changed it, right? And we can see that it's not just in this transaction that it's changed. If we go back to our script and run this script, you'll see it says goodbye idiots, and that's because we actually changed the data on the blockchain with this function. So that's sort of how we change these little variables and that are in our contract here, right? So that's really cool. Now what if we wanted to make it so that in this change greeting function we get to decide what the new greeting is? So let's actually do that. Actually, you know what? Why don't we do this for number, right? So let's go down and say public function change number, and let's say our new number it has a type of integer, and I'll explain this in a second. And we're gonna say, actually, yeah. So the reason that we put this here is because in Cadence, you have to specify the name of your argument and the type of your argument. So we're gonna right here, we're saying we're gonna pass in a new number that has a type of integer. Now, if we wanted more, you would just put comma new number 2, that's an integer, or maybe new greeting. If we wanted to change both in the same one, which is a string, you can do that. But in this case, we're just going to do 1. And then in here, we're going to say self.number equals the new number, right? So we're changing the self.number. And remember, self always means the thing above it. So which is this one. And then equals the new number. So let's go ahead and refresh the page so we can deploy it. We deploy. And boom, deployed to OX01. And so we can go into our transaction here. And instead of, or let's actually make a new transaction. And let's take what we have in here, right? So let's make a new transaction. Instead of doing this stuff, let us say, let's log Jacob.number. And if I refresh here, you'll see it gives us auto completion this time. So we can log Jacob.number, and then we can say Jacob.newNumber or change number. And you can see even if I just press tab here, it'll automatically do it for me. Or that's change greeting. I should say change number, right? Tab. And then we can log Jacob.number again. Cool. Now look at what's happening here. We can actually get rid of this and let's just put like 10 here, right? So dot change number, the argument label, right? So whatever matches this. So we're saying the new number, and that's why we're saying new number here is 10, right? And then log Jacob.number again. Let's go ahead and do that. So let's send the transaction. And obviously something's wrong. So I think I probably have to refresh again. Ugh, so annoying. But let's try and send it. And here we go. So we get 0 and then we get 10, right? So it actually changed it. And if we go to our script and execute the script, you'll see it says 10 now, right? So it actually changed it. Cool. Now, what if we wanted to be able to type into like a input box what we want the new number to be? Well, we could say, let's just call it like, number. And this is going to be an integer. So you can pass in arguments in the transaction up here. And then instead of 10, let's just pass in our number, right? Oh my God, wow, it's usually not this bad. It's being really bad today. And look so you can see on the right-hand side here, it actually comes up with a little number box that we can type in. Let's say like maybe, what is that, 10,000, right? So 10,000, and let's go ahead and send. So it changed 10 to 10,000. Right? And we can even see that it changed that in our script as well. So if we execute this, it is 10,000. Boom. That's all really cool. Now, I want to note one thing. Now, I never use this, but it's important to note that if you want to, right? So if you're sick and tired of writing all of these argument labels, what you can do in your contract is you can put a little underscore and then a space. So if you put an underscore and a space like that, we redeploy this contract. You'll notice if we go to the transaction and like if we refresh now, you can see that it says incorrect argument label expected none got new number. And that's because when you put a little underscore and a space before your argument, you actually don't even have to put this. So we can literally just pass in number like that. So I never use that because personally, I think it's really helpful to read what argument label you're passing in, but you can do this if you want to, if you're like sick of typing it all the time. Cool. So that is how we would change the number, right? So all cool. Now, one more thing that I think is pretty cool to mention is, I keep saying that in the execute phase, you can't access the account, but in the prepare phase, you can access the account, right? So why don't we go ahead and let me prove to you that this account is actually who we're signing with on this side. So let's go ahead and log. This is the address of the signer, right? And then let's log account. So actually, I usually like calling the signer because I think it makes more sense. Well, let's go ahead and log signer.address. And if we do this, let's refresh the page. I don't know why it's doing that. If we log signer.address, look what happens. So if we type in, let's get rid of these logs just because we don't want to see these anymore. Let's type in, I don't know, like 2, send. And look, this is the address of the signer, 0x1. But let's see, what if we sign from account 4? 0x4. So this is proof that you can access the address of the signer right here, right? So that's really cool to know who's actually signing the function. All right. And so all of that, what we just covered, that was all of chapter 2, day 2, to help you figure out a bunch of stuff in your contract. So the quest here is asking you to basically do what we did, which is define a variable and then define a function like that. So we've officially been going for 30 minutes, and honestly, I think that this is where most of you probably are. So we reviewed all of chapter 1 and chapter 2 up to we did day 1 and 2. Day 1 and day 2. So I might leave it there, and in the on Friday we'll go over the rest of chapter 2, because you don't have to, but I recommend that by the end of this week you finish chapter 2 so that next week you can start with chapter 3. So if anyone has any questions about this, just you can totally stick around and I'll answer any questions you have. It doesn't even have to be related to the bootcamp. It could be anything blockchain, or really anything at all. But that's all I have for the workshop today. So I hope this was helpful for everybody.
Absolutely, man. Thank you.
Yeah, this was super great, Jacob. Thank you.
Of course. Thank you so much, Trey and Square Monkey, for saying that. You're welcome, SWT. I love the dancing beat.
Now, one of the things I read today was there was this mint in, I forget what it was. It was an Ethereum mint, obviously. And the person who wrote the contract didn't have this one argument that said, that basically validated that the signer of the transaction was the sender of the transaction, and that allowed someone to do some bot buys and mint like 900 of the NFT in one go.
Yep.
So when you were setting up the in that transaction where you were logging the sender's ID, if I was creating a mint transaction and I wanted to do what that guy on Ethereum was telling Ethereum developers to do on Flow, how would I set that argument up to I guess to log it and then to check that the signer and the I forgot what, and basically that both things are the same.
No, that's a really good question. And this is a sort of a it's a more complicated answer than you think because of the way the cadence works, but I'm going to try to explain it in a way that makes sense. So in Solidity, and for those of you that don't know, Solidity is the smart contract language for the Ethereum. So if you look up Solidity, you'll see it's you can read all about it. But it's basically a different smart contract language that I hate. LOL. But basically, so let's picture we're in Solidity land here, right? So everything I'm writing here is Solidity. In Solidity, you can do something called message.sender. And message.sender basically is the person who signed the transaction. And message.sender is available throughout the entire contract. So I will give Solidity this. This is extremely helpful because what you can do is you can basically have a guarantee that this message.sender is the person that you're going to want to know about, because this is the person that sent the transaction. So what that guy was saying was that in the contract, there was no check that said like message.sender equals an admin that should be minting, right? So anyone could basically go in there and just mint an NFT if they want. I don't know if that was what he was doing, but mint an NFT, right? Now, in Cadence, there's no such thing as message.sender. When you're in the contract, you have absolutely no idea who's the one that's changing the state. Now, this is a problem. It's a problem and a benefit, because the problem is that it's really annoying. The more complex applications you write, the more you want it. However, it's really secure because the way that Cadence is architected is all through something called resources. And resources are given to the account to say this account has admin rights. So what you can do, for example, let's go to a new contract here. Pub contract Fort Monkey. And in here, what you're going to learn in like a week from now is you can make something called the resource. So you can say pub resource admin. Now, you don't have to know anything about what I'm doing right now, but just picture that this is some admin functionality, right? And in here, it allows you to mint an NFT. So what you can do is you can put this admin inside of an account. And the reason this is helpful is because when you put this admin inside of an account, think about what I was saying in the transaction. In a transaction, you can access the signer's account in the prepare phase here. So the way that you would stop that on Cadence is to check, like, does the signer have an admin in their account? If so, call the mint NFT function inside of the admin. And like theoretically, we could just delete all this just for clarity. Theoretically, inside of this admin resource, there would be a function called public function mint NFT, right? And it would return an NFT. And this is the function you would call right here. So you would do like admin.mint NFT, right? Or something like that. And this is really secure because if this signer didn't have an admin in their account, they would never be able to call this because they don't have an admin to call it with. So hopefully that answers your question about like why in Cadence it's an easier problem to solve because you can always make sure that the signer can mint NFT by checking to see if they have the admin to call it.
Yep. Yeah, no, that makes sense.
Yep. Yeah. Yeah, and this is also, by the way, why it's really readable because if we if we open up I'm just gonna open up like an Open Zeppelin ERC 721. So what I'm opening up right now, this is the NFT standard for Ethereum. So this contract right here, it's a lot. It's a lot. And the problem is that in the functions that you want to only be admin access, it's like right here, like mint, for example, you would have to add some sort of checker here to say like, okay, only an admin can mint this. So you would have to manually, as the creator of this contract, remember in your head that you have to put some sort of check here that only an admin can mint this because Solidity thinks this is totally fine. Solidity has absolutely no problem with this. It's like, oh, you want everyone to be able to mint? Go ahead. So it won't tell you as a developer that you're making a mistake. That's very different in Cadence because like if you're in, oh, this is the wrong one. If you're in a contract and you specifically have like a public function mint NFT here, it's really clear that you're messing up and returning an NFT. Whereas like if you put it inside of an admin, it's a lot more clear to you as the reader that it's only callable by an admin.
So, I can't help it because you've got me thinking about this now. So the resource admin, can you apply entropy to that? Like, could you say that that admin can only call the mint function 5 times, and after the 5th call, it removes that admin resource from whatever profile it's in, whatever account it's currently in?
So you can't.
I'm assuming you could because that's just a structure, but I don't know.
Yeah, it's an interesting question. So you can't destroy it per se, but you can disable it because what you can say is you can say public var like mint capacity is a int like that. Here, let's just do this. Why not, right? So, let's just say mint NFT returns. I'll just comment this out for now because we don't actually have an NFT type. But let's make it an int function here, and let's say like self.mint capacity. You said like 5, right? So let's say it's 5. Now, inside of our public function mint NFT, let's say it's going to give me errors. We're just going to ignore the errors. Let's say inside an NFT, every time we mint an NFT, we're going to say self.mint capacity equals self.mint capacity plus 1. And then you add a condition here that says, like, if, oh, sorry, no, not you. And then you would say, like, okay, so this is your capacity. And then you would say public var, like, current number or something, right? And this is also an int, and you initialize self.current number equal to 0. And then in here, you would say self.current number equals self.current number plus 1. And then before you even do any of this minting, you would say like if, self.current number like equals self.mint capacity, then like panic, right? So that's how you would do that.
Cool. Thank you.
Yep.
That's cool to see played out.
Yeah. And actually, why maybe this exists. This exists to some capacity actually in the fungible token standard. Why not? I'll just show you this right now. So this is fungible token. Keep in mind, this is not NFTs. but inside the Flow Team's example fungible token contract, let me actually, I'll copy this to the playground because you have syntax highlighting. So let me just copy this over to the playground really quick. A bunch of errors, but ignore that. So inside of the minter, they actually say there's an allowed amount, and they initialize allowed amount to that amount. And what they do is they say, like, there's a precondition here. So precondition is basically, you'll learn about these in the course, but precondition is basically like a condition that has to be satisfied before any of the other stuff is run. So it says, okay, let's go to mint tokens, and if the amount we're minting, it must be less than the self.allowed amount. If it's greater, then it's going to say like allowed amount must be less, or amount minted must be less than the allowed amount. And then every time they mint, they just say the allowed amount equals the allowed amount minus the amount that you just minted. So it keeps going down until theoretically you just can't mint anymore.
Sweet. Yeah. Okay. And so what we know that we can do is we can go to these are basically just standards documents that we should copy from and just change names, like, yes, more or less, right?
Yeah. So like this is an example. So I'll link this in the chat. So this is in like the example fungible token. So that's an example fungible token. And if you, I mean, yeah, you technically could just like change the types and just make it your own. I mean, I always suggest some like uniqueness, but BC just linked his poop contract that he wrote for Basic Beast. That's his project. And then,
Jacob, I wanted to ask for that example contract. Technically, if they created one more minter, they would be able to, mint more, right?
Yes. Yeah. So if somehow the account was able to get multiple of these, then yeah, they can mint out like, this times the amount that they had.
Oh, but in this contract, they are not able to create more minters.
Mm-hmm.
Right?
Yeah, because the only person that has the minter is the contract that deploys it.
Okay.
Or where is it?
And the admin in this contract isn't able to make more.
Actually, no,
resource.
I'm wrong about that. So in this example contract, there's something called an administrator, and only the contract that deployed it has admin, and then this admin can make more minters. Yeah,
this is actually quite strange because this means that because it's based on the flow token as well, and as far as I remember, technically Dapper Labs, they're able to create more minters from the admin account. If they still have access to that, and they're basically able to create more flow tokens.
Oh yeah, I mean, we can all go ahead and let's all look at the contract for flow token. Now, of course, this is going to be too complicated for everyone right now, but by the end of this bootcamp, you will understand everything about flow token, by the way. So just want to mention that as well. But core, I am proud of myself, by the way, for this bootcamp, because I promise if you finish this bootcamp, you'll understand like 90% of contracts on Flow. I swear to you. All right, so flow token. So if we actually go to flow token, let's actually look at it on mainnet. So we can actually view literally the contract on mainnet. Let's go ahead and this is how I view the contracts. Go to the view source. So we can actually look at flow token. So every time that you buy or trade flow token, this is the contract that's handling it. So you can see it's not that long. I mean, look at it. It's not that bad. It's what, 200 lines of code? That's like nothing compared to some of the scary beasts I've seen. But you can see that inside of here, like, oh, and I just want to mention really quick, I know I've been hammering in this point, but think about how cool it is that I mean, I don't know if any of you are really understanding this, but think about how cool it is that all of you literally, we just wrote a contract that literally has a number in it, and that's it. And I'm somewhat able to show you an entire flow token contract. It's kind of cool in a way, even though it might be a little confusing. Some of the concepts you can definitely understand, but anyway, yes. Look at the flow token contract. So the flow team gives themselves an administrator right here. So they create an administrator and they save it to their account, right? Account.save. You'll learn all of this, by the way. So, and look at what the administrator can do. The administrator can create a new minter and create a new burner. So technically, if the flow team didn't throw away their private key, which they didn't, you can see it's still here, they can create as many minters as they want.
Nice.
Yeah.
On burners, because this is a almost like a philosophical thing I don't fully understand with regards to crypto. Like, isn't like can't you burn something just by sending it to a wallet that doesn't exist? Why do you need a specific function for burning tokens? That's something I don't really understand yet.
Well, it's common practice on Ethereum to do that. Not so much on Flow. One of the reasons. What, BC?
Oh, I just wanted to say I don't think you can do that on Flow.
Yeah, they're also exactly. There's no such thing on Flow as a dummy account. There's no such thing. So on Ethereum, you can just send all your tokens to like wallet 00000. On Flow, you can't do that. But besides the point, on sometimes I don't know. Wait, let me actually check. Do they do that? Hold on one sec. I want to see if they do this. Yeah, they do. They do. Okay, cool. So inside the Flow token contract, they have something called a total supply, and this is the total number of Flow tokens in existence. So this total supply should reflect the amount that are like alive, right? So if we go down here, first of all, if we were to send them to a null address, which we can't anyway, but if we could, this would still contain those tokens that are non-existent. And think about the problem with that if you have something like a staking contract or a liquidity pool, right? You know, where total supply matters for pricing, you want this to reflect the amount that's out there. And you can see that so I'll just explain this to you. You don't have to understand this yet, but the vault is what stores your tokens. When the vault gets destroyed, so when it gets destroyed in the destroy function, it says the Flow token total supply equals the total supply minus the amount that was in that vault. So it keeps track of all the Flow token in existence. And the burner.
Okay, now that makes sense.
Yeah, and the burner simply takes in a vault and destroys it. And when you destroy it here, it calls this destroy function that takes away the total supply.
I wonder if we should ever ask Dapper about the Flow token, like about them being able to mint more Flow.
I mean,
Because
I guess they kind of have to though, right? Because in order to because they constantly mint more Flow token, like constantly. Because they I'm pretty sure the way I don't know this for sure, but like I'm pretty sure like one of the more common things to do with like investors is to like lock tokens for like 5 years and just mint more and just say like you'll get these in 5 years or something.
Oh, I actually thought that they pre-minted all Flow tokens and then they just locked because they have like the lock contract, and then they have put some Flow tokens in the staking pool, and that's it.
Yeah, no,
But
they
I'm not.
actually they do mint Flow token quite often.
Oh,
Yeah. Just retweeted Claymore's tweet, no biggie.
well, I'm really surprised like how many people are actually, like in this office hours. Like it's totally different from Fast Forward, like at Decentology.
I know, right?
Yeah. I'm a little bit sad about that though, because I like to have you for myself, just like all office hours, and I just come with basic B smart contracts and like please review all these, and yeah.
Yeah, for those of you that don't know, I actually ran a boot camp called Fast Forward. Like, maybe how long was it? How long, BZ? Like maybe like 8 months ago. No, wow, time flies. Oh my god.
It's September, something like that.
Yeah, no, I think it was August. I think it was like 8, 9 months ago, or no, it was like 6, 7 months ago. And BZ was the best participant in that boot camp. So BZ's already the master here. But yeah.
Nice.
Yeah, so yeah, so like I said, that's it. I'll be here for a couple minutes in case anyone has any questions. but you can totally feel free to go. And keep up the great work. A lot of people in here have been submitting really great quests, so keep doing it.
Yeah, again, thanks a lot, Jacob. I'm gonna split, but yeah, this has been really great, and I'll see everybody on Friday.
Awesome. I'll see you Friday, Trey. Peace. And if anyone has watched Attack on Titan, I would love to talk about that as well. But that's not related to blockchain at all. Thanks, BC.
So I saw on one of the updates, I don't know if it was yesterday or the day before, that they're introducing the new metadata or more elements of the metadata standard, particularly NFT types and I think IDs or some other kind of ID. It was on the Flow Discord.
Interesting. Interesting.
The in terms of like types of NFTs, do you think that there's gonna be like right now there's just the one NFT standard, right? Like they don't have any other NFT standards. Can anyone write their own though? It's just gonna take longer to get approved. Will it not matter, or do we have to call their NFT standard?
I mean, technically, I could write my own metadata standard if I want to. But it's sort of like the point of the standard is to. It's almost like the non-fungible token standard. I can make my own standard, but like no application is going to support it because everyone else is using the main one. You know, so it's sort of like everyone's going to use the metadata standard, and they should because BRTech's done a great job with it. So that should that will become like the main thing for sure.
Cool.
The only issue that I have with the metadata standard, and that BRTech also has with it, is that it requires the Flow team to manually add the different ways to view the NFTs, which is super manual and super like annoying because like it's they don't have that much time to be doing this kind of thing, and it's kind of important to get different views out there because what's the point of a metadata standard if there's only 2 ways to view an NFT? There has to be like hundreds. All right, everybody. Thanks for coming to the workshop. And I will see you on Friday. If you can't make it, that is totally fine. I will have it recorded. I'm going to post the recording to this one so you can all see it if you want to. And yeah, see you soon. Keep up the great work. You're welcome.
See you Friday, mate. Thanks.
See you, Sport Monkey. Bye. Bye, 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 bye. How do you create? So Bam asks, like Kelcoin. So Bam asks, how do you create a minter and deposit it into others' account with the admin resource? You need dual authentication. Yeah, you need double signers. That's the only way to do it. So if we actually go to, which by the way is not a good, like that's not like that great, but if we actually go to github.com/flowft, I think. No, God, what am I doing? Yeah, flow ft, I think. So we can actually go to the transactions here, and it should be called what? Burn tokens, create forwarder. Mint tokens. What? So it looks like they don't have that example, but that is what you would do. You would create the mint resource in a transaction, and then you would just deposit it into the auth account of, like, you would save it to the other auth account. For some reason, that's not how they're using it here, but that is how you would do it. Of course. Bye, Bam. All right. Bye, everybody. I am still recording.